Namaste. Last class we have discussed about different types of footings like shallow footings and spread footings. So let us see the syllabus. We are in fourth chapter of BMCP. So we have completed the component parts of a building, classification of building, site investigations, bearing capacity of the soil. Also yesterday, last class we have completed, and spread footing, raft foundation we have completed, and piles also we have completed, and different types of loads to be considered in the design. Today I am going to be taken, and spread foundation, design of spread foundation also today is our topic, right? So even construction for foot foundation, only steps only, construction of foundation like spread footing, only steps we can cover here. So this is our today's target. Let us see the presentation. Yeah. Yeah, this is today's target, like different loads to be considered for the design of foundation as per the IS 875. Calculate the width, depth of the spread foundation, uh, and the thickness of the foundation. Also, will concentrate on different loads also, right? So there are different types of loads are generally coming on the building foundations. Those are called dead loads, live loads, wind loads, snow loads, earthquake loads. Based on these loads, we'll design the building, right? And based on these loads, we'll test the soil for the bearing capacity. Whether these loads cumulatively will taken care by our soil or not, right? So based on that, we'll construct the foundation, right? And regarding, if you see the what is a dead load is not it is means not is a dead. So dead load means self weight of the structure. It is called as dead load. The what will be the whatever the self load mm, consisting by the structure, the self load itself is called as a dead load. Live load means a moving load, like human beings, or if you take a bridge, the vehicles are coming and going out, like whatever the moving loads coming onto the structure, those are called live loads. And wind loads are generally, these are loads due to wind, and the snow loads, load due to snow falling or snow. And earthquake load is very what you can say, very rare occurrence load, but our building should be constructed to resist the seismic effect also, earthquake effect also, right? So I would like to show the different codes which are given by Bureau of Indian Standards for different loads, like 875 part 1. So let us open all at once. It's 875 part 2, 875 part 3, 875 part 4, 875 part 5. These are the five codes. So let us see one by one. Just we'll see the overview of the codes. Right. The IS 875 code is related to design loads other than earthquake loads for buildings and structures. Right. So IS 871 part 1 is regarding to dead loads, means unit weights of building materials and stored materials. Let us see the overall view of the code. We'll see all five parts, so that you'll get an idea that code how can be reflected. Right. If you this code, IS 875 is explaining in the following five parts. Part 1 is dead loads. Part 2 is imposed loads, that is nothing but live loads. Part 3 for in loads. Part 4 for snow loads. Part 5 is combination of loads Special loads and combination of loads. Earthquake loads is covered in 1893, not covered in this one. So even if possible, I will show 1893 also. Please remember that number so I can show that also. Right. See, this code it is covered. The unit weight of materials I have given here, like ascotic materials, glass fiber, hair, like cork. If you see the coarse aggregate, broken stone ballast, unit weight is in kg per meter and kiloton per meter square. You can say, see here, 15 to 18, right? So if you see, take same taking in. Kg 600 to 1870, right? Even bricks, right? See, sand, fiber, asbestos, natural spray, cement pressure pipes, bitumen, cork boards, standard hardboard materials, high density wood particles. See, common burnt clay bricks, 1600 to 1920 kg per meter cubes, the unit weight. Based on this unit weight, if you first of all you will calculate the how many bricks are occurring in 1 cubic meter of a masonry. One brick is 1 meter cube brick is weighing like this. So based on that, we will calculate the loads, right? So I see different materials like cement concrete. See, plain cement concrete. Pre-stressed concrete. See, 2400 kg per meter cube or 23.5. So dead load is are calculated based on the unit weight of the material. Every material unit weight has been covered in even the C channels. Unit weight of building materials like channels, IS, Indian standard angles, right? Equal angles, unequal angles, beams. So everything unit weights have been covered in this IS 875 part 1. So like this we can take unit weight of material whatever we are taking into the building design. So we'll calculate the loads accordingly, right? Next, IS 875 part 2. If you see the part 2, it is related to imposed loads, means live loads. How live loads can be assumed, right? How live loads are coming onto the building? How can we ascertain that? So these live loads are calculated based on the utility of the building, right? For what purpose you are constructing the building? Based on that, the live loads are designed, right? See here, following important changes have been made. It the live load has been modified as imposed load. So earlier it was calling as a live load, right? So the direction of imposed loads for design of vertical supporting members in multi-storied buildings has been further increased to 40 to 50%. So these are the terminology that we will consider on the uh, values. Imposed loads to be assumed in the design of buildings shall be greatest loads that probably will be produced by the intended use of occupancy, but shall not less than the equivalent minimum load specified in table 1. Right. The floors shall be investigated for both the uniformly distributed loads and the corresponding concentrated loads are specified in table 1. Let us see the table 1. Yeah, this is table 1. Yeah, correct. See here, residential buildings, dwelling houses, all rooms and kitchens, uniformly distributed load 2 kilonewton per meter square, and concentrated load is like this. You can take toilets, corridors, right? So if you see balcony, see this is all dwelling units of paneled executed in accordance to the paneled doors, right? Like this. Hostel buildings, if you take houses like this, living rooms, kitchens, billiards, storerooms, dining, these all included the total live load of the hostel building, right? Boiler rooms, see educational buildings, let us see. Classrooms, lecture rooms, dining rooms, cafeteria, office, lounges, staff rooms, dormitories, projection rooms, kitchens, toilets and bathrooms, storerooms, libraries, right? So also library also mentioned some categories, reading rooms, boiler rooms, corridors. These all are included in calculate so that the total load arrived, that is called a imposed load to be on the educational building, right? So dead load we can calculate from unit weight materials. So live load we can calculate it from the code, like institutional buildings, right? See assembly buildings. What how the buildings are classified in classification as per NBC. Same in that fashion. It is shown here. Assembly buildings, educational buildings, business offices, right? So mercantile buildings, industrial buildings, storage buildings, right? Likewise, the values have been given in code IS 875 part 2. These live loads, those dead loads are taken by IS 875 part 1, and live loads are taken by IS 75 875 part 2. These collaboratively or cumulatively we can take as a load whatever coming onto the building, right? So next we'll see. So yes, part 3, that is wind load. How wind load is calculated, right? See, this is a formula mathematically expressed like this. Design of wind speed, basic wind speed, nature of wind and atmosphere. Design of wind speed can be mathematically VB, K1, K2, K3. VB is the design of wind speed at any height Z, probability factor or risk coefficient, terrain and height of the structure, and uh, topography factor. Based on this speed, wind speed can be designed, right? Uh, See, this is interesting figure what it is showing. So different wind conditions it is showing, right? See factors K1, K2 factors is given here, right? How K1 is calculated. So based on this, we can take the wind loads of the building, right? This is the code which we can take as a reference to calculate the wind loads from IS 875 part 3, right? Then we will see the fourth one. What is this? Snow load, right? How snow loads are calculated. Some notations also given. Snow load in roof coefficient is given. Shape coefficient S is equal to mu into S naught. These are the formulas which is given for the slope of the section. These are the formulas which we can calculate the snow load as an ideal buildings. This is the code which can be referred for the calculation of snow load. Now finally, special and combination loads we can take from this. So let us see the code that is 1893 also, if possible. So I'll show my screen. I can be see my screen also. I can show the IS 1893 also if possible. So this is 93 standards, IS standards, IS codes 1893. Yeah, it is there. This is the code which can be taken as a criteria for earthquake resistance design of structures. So I'd like to show how the different zones are there. See, these are the various zones. Yeah, see here. So India is divided into six zones: Zone 1, Zone 2, Zone 3, Zone 4, Zone 5. See, Zone 1 is white, this one and this Hyderabad part. So Zone 2 is blue part. Zone 3 is yellow part. Zone 4 also yellow. Zone 5 is the pink part. Yes, Bhuj. Right. So like these are India is divided into five zones, right? Based on that, we can calculate seismic loads and we can design the buildings according to the where it is lying the building, which zone, right? So the ultimate load design for steel structures can be calculated as dead load, live load, and earthquake loads, right? This is the formula. See, depth below ground level in meters. For zone 3, zone 4, zone 5, up to 5 meters you have to go. And zone 1 and zone 2 is up to 5 meters for structures only. N value is given like this. Right. These are some values of basic coefficient of seismic zone factors in different zones it is given. See, load class has given like this. This is how the code reference has been taken for the seismic effects. So seismic coefficient method, the seismic force be resisted shall be computed as follows. Right, right, okay, friends. Likewise, we will calculate all loads uh, which are taking from different code references are cumulatively taken for calculation of different loads. So load calculation is very very important. Based on the load calculation only our design is based, whether we can go for what type of building, and even soil bearing capacity also can be compared by the load calculations what we get, right? So we'll see a small video if possible. Yeah, it is coming. Yeah, two windows are open. It is closed so that the other one will be open easily. This is showing different loads which are coming onto the building. Wow. మమ్మీ నేను ముట్టుకోదా ముట్టుకోవచ్చు క్లాస్ అవుతుంది పబ్లిక్ క్లాస్ మళ్ళీ ఇది వచ్చింది ఇది క్లాస్ అయితే నాకు తెలుసు Yes. So these are the some loads which are taken into the building. As already again explained, dead load is a permanent, immovable and non-transferable load at the structure, like self-weight of the uh, elements of the building. Uh, Dead load, right? It includes the weight of the building components like walls, floors, etc. The weight of fixed water tanks and roofs, the weight of machinery and equipment will include as a dead loads. The loads can be calculated by two ways: unit weight per volume, expressed in kg per meter cube, or unit weights per unit surface area, weights per unit surface area expressed in kg per meter square also. Dead loads, yeah. Dead loads are structural loads, structural items, dead loads of some structural items as per IS 875 has given. See, cement is 1440 kg per meter cube, bricks is 1600, concrete is 2400, limestone is 2560, rubble masonry is 2000, steel is 17850, and unit cement mortar is 2080. Dry sand is see, apart this highest value is steel, right? Steel is having highest value of mm, what you say, dead load, right? Flooring is also given. So see, these are expressed in surface area, kg per meter square. Here highest value is country tiled roof is consuming. Live loads, it is a temporary or movable or transferable load acting on the structures. It includes weight of the inhabitants, weight of furniture, stored material. Those loads can be calculated by unit weight, weight per unit surface area expressed in kg per meter square. Some live loads are given as residential buildings, uh, 2 kN per meter square, offices 2 to 4, floors for banking halls, entrances 3, workshops and dancing floors 5, shop floors is 4, floors of warehouses is highest, having taking loads of heavy loads, warehouses 7.5 kN per meter square imposed loads are giving, and these loads are assumed to be acting uniformly over the whole area. These loads do not take into account special loads like heavy concentrated loads, vibration effects of the machinery, right? So reduction of load. In case of multi-story building, some reduction is allowed in different floors, as it is assumed that all the floors of a building are not simultaneously loaded at the same time. So number of floors carried by the number of members of the construction. If single floor percentage reduction is 0, if two floors building is there, percentage of the reduction of live load is 10, right? uh, if for 3 20, fourth floor 30, 5 and more floors 40% reduction in total live load can be allowed. No reduction shall however be made in the case of warehouses, garages, other than buildings used for purpose of storages, factories, even though they are constructed for higher floors, right? Wind loads, it is the load exerted by the wind on exposed faces of walls, inclined roofs also. And orientation, for the purpose of design, it is assumed that the wind is acting horizontally at a uniform rate on windward side. The wind effect of wind is to overturn the building. The effect of this wind pressure is practicably negligible in the case of low height buildings. Snow loads in hilly regions where there is snowfall and the snow is deposited on the roofs of buildings, the load due to snow will have to be considered. And in snow load, in absence of any specific information, the loading due to the snow may be assumed as 25 Newton per meter square per centimeter depth of snow. In the case of roofs with slopes greater than 50-degree, snow load may be disregarded, and the structural design of spread footing LC. So the design of foundation consists of determining the width of the footing, depth of the footing, and thickness of the foundation concrete block. Three elements important for the spread footing. The width of the foundation should be sufficient to sustain the superimposed load, means live loads, combination of all loads on the structure. The depth should be such that it should resist the yielding of the soil. So the width of the foundation is calculated on the basis of uh, the width of the foundation on the basis of the total loads of the safe bearing capacity of soil, and width of foundation is given by W by P, where W is the total superimposed loads consisting the live load, dead load, live load, wind load, snow load per running meter or per unit length. P is the safe bearing capacity of the soil. In case of hard soils such as muram rock, the above formula can be the above formula may be give sufficient with the width sand, but may be insufficient to meet the required requirement of stability and or requirement of stability or safety against tilting or overturning. Um, with the foundation to overcome this difficulty, the thumb rule has been devised to determine the width of foundation to meet the requirement of stability. The width of the lowermost masonry footing should not be less than twice the thickness of the wall, and width of foundation is 2t plus 2j, where t is the thickness of wall and j is the concrete offset which is given, and the width of foundation shall be as maximum of W by P or 2T plus 2J, both formulas, but maximum value of these two values will take, right? And depth of foundation, the depth from the natural ground level to the bottom of the foundation is called as the depth of foundation. So factors affecting depth of foundation, the depth of foundation at which required bearing capacity of soil is available. When the foundation has to be constructed on a pond, water course ditch filled with soil, it should either be taken as to a depth where such conditions do not produce any adverse effect. In case of a black cotton soil or clay soils, it is dependent upon the depth up to which the effect of volumetric changes in soil do not produce any adverse effect. So minimum depth of the foundation is in general the depth of foundation, the depth up to which the soil is weakened by root holes or cavities produced by animals or worms, etc. Is taken as minimum depth. Scientifically, the minimum depth of foundation to prevent the soil moving laterally under pressure is determined commonly by Rankin's formula. Depth of the foundation is given by D is equal to P by W 1 minus sin phi by 1 plus 1 minus sin phi whole square by 1 plus sin phi whole square. So where D is the depth of foundation below the ground level, P is the load of the structure per unit area, and W is the unit weight of the soil weight of soil per unit volume. So phi is the angle of repose of the soil. So how the angle of repose? What is the angle of repose? It is the angle between the horizontal and the maximum slope that a soil assumes after attaining stability. The angle of repose of some soils are, so the very wet earth or clay earth, the angle of repose is 15 degrees, and moist and shingle is 40 degrees, dry earth is dry sand is 30 degrees. Next is the thickness of concrete block. The purpose of concrete block below the footing are to bridge over small faults in the subsoil by acting as a simple beam to provide a leveled surface for the masonry footings to cover Inequalities of the excavation. The thickness of concrete bed depends upon the following factors: cement concrete or lime concrete. The projection of the concrete block behind the uh, bottom most course of a wall footing, upward pressure of the soil underneath the footing, and the thickness of the concrete block can be determined by the following formula: D is equal to square root of 3p x square by m, where D is the depth of concrete in centimeter, P is the net upward pressure, X is the concrete offset, and M is the modulus of rupture of the concrete block in kg per cm square. Right. See here, this is the upward pressure. X is the projection of the concrete block. Right. So modulus of rupture, the modulus of rupture of the maximum bending stress calculated on the assumptions that elastic condition exist until failure. So modulus of rupture of concrete is lime concrete is 1.55, cement concrete is given 2.46, and different grades of cement also it is given like this modulus of rupture in. So since the resistance of concrete to tensile and shear stresses is low, the value of J must be limited. The least value of J should vary from 10 to 15 centimeter, means offset. The depth of concrete block can also be calculated using the thumb rule. That is, D is equal to 5T by 6. T is the thickness of wall in superstructure. So this is another formula. Thus it is important to note that the depth of cement and lean concrete should in no case be less than its projection behind the masonry face. In case of lime concrete, the depth of bed block should be at least 1.5 times its projection behind the masonry face. So let us see a small video also. Just wait. This video shows the construction procedure of stepped footing. Yeah, this is how the staple footing has been calculated, constructed. So we have studied, we have discussed different types of loads and code provisions and their effects on foundation, calculation of width and depth of solid footing and thickness of concrete build block also, factors affecting depth of foundation and angle of repose also we have seen, and different questions also there, like what are the different types of loads have to be considered in the design of foundation, and explain the method of calculating the width of the foundation, and state the factors affecting the depth of foundation. Explain the formula under formula used for calculating the thickness of concrete. These are the uh, what we have discussed today, and so this is today's class.